Imagine Earth as a newborn planet, still reeling from its violent birth. This is the Hadean Eon, a time period so ancient and extreme that it makes the age of dinosaurs feel like yesterday. Spanning from about 4.6 to 4 billion years ago, the Hadean is named for Hades, the Greek god of the underworld, and for good reason. This period was a true inferno. The Hadean is not a time period we can easily study. Rocks from this eon are incredibly rare, victims of the very forces that shaped our planet. But by piecing together evidence from meteorites, lunar samples, and the oldest surviving Earth rocks, we can begin to paint a picture of this formative epoch. Our understanding of the Hadean is constantly evolving as new discoveries are made. But one thing is clear: this was a time of unimaginable heat, violent collisions, and the very first steps towards the Earth we know today. So let's take a journey back in time to the Hadean Eon, when our world was young and full of fire. Our story starts not on Earth, but with the birth of our sun. About 4.6 billion years ago, a giant cloud of gas and dust called a nebula began to collapse under its own gravity. As this cloud contracted, it spun faster and faster, like a spinning figure skater pulling in their arms. At the center of this swirling nebula, pressure and temperature skyrocketed. Eventually it became so intense that hydrogen atoms began to fuse together, releasing a tremendous amount of energy. Our sun was born, bathing the surrounding disk of dust and gas in its light and heat. This leftover material, the remnants of the sun's formation, would eventually coalesce into the planets of our solar system, including our own Earth. But this was no peaceful process. It was a chaotic and violent time, marked by collisions, near misses, and the constant pull of gravity. In the swirling disk around the young sun, dust grains began to clump together. These clumps, drawn together by electrostatic forces, form larger and larger bodies called planetesimals, the building blocks of planets. Over millions of years, these planetesimals collided and stuck together, gradually growing in size. Some of these collisions were glancing blows. Others were head-on impacts that released tremendous energy. The early solar system was a cosmic shooting gallery. One of these growing planetesimals would eventually become Earth. As Earth grew, its gravitational pull increased, attracting even more planetesimals and adding to its mass. This process, called accretion, generated immense heat, turning the young Earth into a molten ball of rock and metal. While the early Earth was still taking shape, a cataclysmic event occurred that would forever change our planet and its destiny. A Mars-sized object, which scientists have named Theia, slammed into the proto-Earth with a glancing blow. The energy released from this impact was unimaginable. Molten rock was blasted into space, forming a ring of debris around the Earth. Over time, this debris coalesced under its own gravity, eventually forming our moon. This giant impact hypothesis, while still debated, is the leading explanation for the moon's formation. It explains the moon's relatively large size compared to Earth, its unusual composition, and its orbital characteristics. The early Earth was nothing like the planet we know today. It was a hostile and alien world. The surface was a magma ocean, a churning sea of molten rock punctuated by volcanic eruptions that spewed lava and gases into the primitive atmosphere. The sky would have glowed an eerie red, illuminated by the constant flow of lava and the intense heat radiating from the Earth's interior. There were no oceans, no continents, just a fiery expanse of molten rock. The very air was a toxic mixture of gases, including nitrogen, carbon dioxide, and water vapor. But lacking the oxygen we breathe today, it was an environment utterly inhospitable to life as we know it. Section 6. The air we cannot breathe. As the Earth began to cool, the water vapor in the atmosphere condensed and fell as torrential rain. This rain, however, would have evaporated back into the atmosphere almost immediately upon contact with the hot surface. This cycle of rainfall and evaporation played a crucial role in shaping the early atmosphere. Water vapor, a potent greenhouse gas, trapped heat from the sun, keeping the Earth extremely hot. Over time, as the Earth continued to cool, some of this water vapor remained in the atmosphere, while the rest condensed and collected on the surface, forming the first shallow oceans. These early oceans were acidic and hot, a far cry from the life-giving waters we know today. Section 7. A reign of fire and ice. The early solar system was a chaotic place. Leftover planetesimals, ranging in size from small asteroids to objects hundreds of kilometers across, bombarded the inner solar system, including Earth. This period, known as the Late Heavy Bombardment, lasted from about 4.1 to 3.8 billion years ago. These impacts delivered even more heat to the Earth, further delaying the cooling process. But these impacts also brought something else: water and organic molecules. Comets, icy remnants from the outer solar system, are rich in water ice and organic compounds. Scientists believe that these impacts played a crucial role in delivering the building blocks of life to the early Earth. Section 8. The seeds of life. Despite the hellish conditions, the stage was set for life to emerge. The ingredients were all there: liquid water, organic molecules, and a source of energy from the sun and geothermal vents. Exactly how life arose from this primordial soup remains one of the biggest mysteries in science. But somewhere in the depths of the early oceans, or perhaps in shallow pools of water on the surface, the first simple life forms emerged. These early life forms were likely single-celled organisms similar to bacteria. They were able to extract energy from their environment and replicate, passing on their genetic information to future generations. Section 9. A time capsule of our beginnings. The Hadean Eon is a time shrouded in mystery. The intense heat and geological activity of this period have erased most of the evidence of Earth's earliest history, but what little we know paints a picture of a dynamic and violent time when our planet was forged in fire and shaped by cosmic collisions. The Hadean is a stark reminder of the incredible journey our planet has taken. From a molten ball of rock to the life-sustaining world we know today, Earth's story is one of constant change and evolution. And while the Hadean may seem like an alien and distant past, it holds the key to understanding our planet's origins and the very emergence of life itself.